Additive manufacturing has been a hobby in a big time for quite a few players, let's say Siemens, GE, and such. Those are typically working in the ultra-high value-add businesses such as aerospace and energy industry, specifically for the gas turbines in the case of Siemens. And it's also a playground for big companies. However, what about the rest of 99% of the companies and industries? Should we also find some place for AM innovation? I'm Juro Aukala, working as an innovation manager in 3D printing, in additive manufacturing in Wärtsilä. And in this presentation, I will describe a framework, how to move forward with not so typical industries in AM, how to engage in collaborative development with SMEs, small and medium enterprises, and really also propose some actionable steps, how to get there. So a little bit about our industry. So I'm coming from an industry that we're dealing with heavy tools, angle grinders, sledgehammers, and heavy swearing during the operations on a daily basis. So typically this is not the most useful environment for the additive manufacturing. But during this presentation, I will share some couple of examples also from our AM journey. But then a couple of words from our sponsor, which is my employer. So about who we are. As Wärtsilä, we employ approximately 18,000 people, turnover approximately 6 billion euros annually. We operate in two main segments, in marine and in energy industries. So this is just a sneak peek on the offering, what we provide for the industry in the marine side. So basically all the other systems in the ship that you can see here, than the steel structure, which is the hull. All the rest we are dealing with. Approximately 1/3 of engines in the marine vessels are provided by Wärtsilä, and so every second ship is serviced or maintained by Wärtsilä globally. So this means tens of thousands of engines globally that we are actually dealing with. Also about CO2 emissions, marine sector is contributing about 5% of the emissions globally. So we are in the forefront really, in the center of sustainability, bringing this decarbonization in the industry. And that's actually also our purpose, to shape the decarbonization in marine and energy industry. Our strategical statement is that we enable sustainable environments through innovation in technology and in services. Sustainable societies. Sorry. But nevertheless, this is how our core product looks like. It's a 4-stroke engine, and there is a guy for scale. So we are dealing with big iron. And that was also one of the first comments that I received when I entered the house, 2017 as a young boy. The old timers were saying that, okay, yeah, but look at the product. What can you 3D print with your small little Ultimaker or shoebox size of a metal printer? Doesn't make any sense. About the product itself, this is Wärtsilä 31 engine. It means the piston is approximately 31 centimeters in diameter, one piston. Overall energy production of this system is approximately 10 megawatts, which is approximately 100 times more what you all guys have in your car engines. So this is quite a beast. These guys are consuming approximately 1 cubic meter of fuel each and every hour this is operating. But this is something about also in which kind of industry we're dealing with. At the moment, we're living in a VUCA world, which is short for volatility, uncertainty, complexity, and ambitious things. So it means that when we're talking about decarbonization, everybody's talking about it. Everybody wants to enable it. But how to make it happen in a nowadays industry based in fossil fuels is that we are having actually multiple different options that nobody knows which is going to be the winning card. So that comes into this flexibility. We as a company, we have to provide this flexibility so that eventually, when things will get clearer, we are having selection of solutions for each and every of these options. Let's say that we have 5 different fuels compared to the fossil fuels that we had in the past. It's quite an interesting position at the moment, I have to say. But for us in the AM, it's actually quite good news. We can deliver. We can deliver flexible and innovative solutions in a quick manner, and also deal with the phenomenon that we have never seen before. But that's only one half of the whole situation. It also has to be affordable, meaning that, as mentioned, the fuel consumption is one of the key driving factors throughout the life cycle of an engine. The other one is the cost, initial cost. So we have to win in both of these fields in order to actually make an impact, which we want to make. If we make the best product in the market, nobody wants to buy it. If we want to make the most cost-efficient product in the market, but it still sucks in the life cycle, nobody's going to still buy it. And yeah, new fuel development is really rigorous at the moment. These two things, flexibility and affordability, we also started to target back in the day, 2018, where we started our team. We started with small little things on the shop and factory floors. You can see some of the high-performance tools that we came up with thanks to 3D printing. All of these joint pieces has been 3D printed, and rest of the structure is just pipe structure. We were able to achieve 80%, 90% cost reduction and weight reduction, both. And this is only impacting the factory floor already. So we knew that, okay, we are in the right field. Major part still of our production in the polymer side, we're employing approximately 15 FDM printers in our factories. And then we are printing approximately 1,000 kilograms of PLA and other polymer materials per year at the moment. So we're printing quite a lot, thousands of easy peasy pieces that we need when we manufacture our products. That's the first goal that we achieved. But that's only one part of our story. How is it going to be? Yes. The second step that we took also addresses the affordability side. These are 2 of our products that on the left-hand side, the leak block, it's the size of this like a football, 1.2 kilograms of printed part. We are going to serialize that. I believe that the start of the assembly of this engine, the first engine will happen this December. So that's going to be one of the serial part in our engines because it makes more sense cost-wise to make it by 3D printing than manufacture it by machining. The other part what we see here is old versus new one. On the right-hand side, you can see the new one, which is 3D printed, utilizes design freedom, and it's approximately 98% less weight, and it's also more cost efficient than the conventionally made one. There you can see quite a huge difference on the system and the part cost level that we are able to get into the systems that we produce. So again, this is the same part. It's doing exactly the same function, but it looks completely different. And that is also one of the challenges that we have, because nobody in their right minds would actually believe that we are able to do it without seeing an actual, showing the example that actually works. But this is not the whole truth. The examples that I showed, those are only mainly from the left-hand side. Our actual target for shaping, again, the flexibility, shaping the decarbonization, those are happening on the system level and also the performance part level. It takes time, it takes year We are now on the 7th year of development, and finally we are reaching those 2 levels. Only the first examples, but we are getting there. And I would say that we are more or less mastering now the 2 of the left-hand side sections. This is the roadmap that we have been following since 2018, and again, importance on the right-hand side, it's getting more and more important. Yeah. I just wanted to show that, yeah, we are also doing other things than what we are showing here. But again, so what? Does it really matter that we are good if our supply chain, which actually produces 70% of our products, is way below what we are understanding on the additive manufacturing? You know the answer. So again, we have to strongly affect also the SMEs, small and medium enterprises, who are actually, as you heard, forming majority of our company in terms of manufacturing volumes. And this is also the business, actual business that AM can make happen if this big segment, as mentioned, 99% of the industries are not that familiar with AM yet. We want to change that. And we want to be the living proof that this is actually possible. We can start breaking down by understanding how nowadays OEMs, so such as Wärtsilä, I'm not referring to AM OEMs, but the users, the somebody who's utilizing AM as OEM. And then we have the SMEs, typically, for example, small machining workshops who are delivering parts and solutions for us. There you can see what are their main interests. OEMs are obsessed only on their parts, whereas SMEs, they are obsessed with proven technologies so that they can do reliable business. Typically, also the flow of ideas, flow of pressure, it comes from the bigger ensemble on the smaller side. One direction. And then we have something in common, which is the development. Just to highlight, it's there. It's small, but it's there. And then what about the novel technologies such as 3D printing? Do we have space for that in this kind of like model that we are having more and more in the industry? No, unfortunately. It's really like something that people are referring as that, yeah, in future, in 50 years, additive manufacturing probably will change the world. These kind of lines you will hear. But it doesn't play any role in significant way on the strategies of either of the companies. And again, 70% again from Wärtsilä things are produced by these SMEs. Somebody should take care of AM as well. But then, how to move forward? How to involve these smaller players? As said, we are not even the bigger brother ourselves. We are considered, in Finland, we are a big company. But on a global scale, there are much bigger players. We have been thinking about these ecosystem models quite a lot, because we are part of many. There are basically 3 different families of ecosystems nowadays. Technology innovation, operational, or then knowledge-based, which is, let's say, the lowest level of ambitious and practical things. Typically, these are quite monolithic, which means that they have a clear leader and then clear follower. Again, this flow of information is one side. However, what we propose as the better model is what we call collaborative leadership, which we only want to be one player in the whole thing, which means that we want to lead sometimes, and then we want to give the leadership for the others in some other ways. This is really like a neuron, so that it's not fixed, but it's instead quite a dynamic way that how do you change your role. This is very easily presented here. Nice graphs and so, what do you think? But then going to the practical side, how to do this and how to make this happen. Obviously, the most important one is affecting the people. Recently, 3 years ago, we were one of the founding members of FAME, Finnish Additive Manufacturing Ecosystem. This was the leading vision from the very beginning, that we want to actually make people to talk to each other. I don't want to be the only bottleneck. in these conversations. We want to really empower the people to actually form meaningful relationships so that I can call people in my supply chain so that we are actually growing together and not only that I'm telling you to do some things. But that's only one part. We have to get practical as early on as possible, and this is done by two ways: shared assets and also shared platforms. Shared assets, I'm going to show on the next slide what does it mean, but shared platforms, it can mean really that we're connecting ERP systems, that way we know what are the other SMEs doing so that eventually they can supply, for example, the OEM some solution. This is not working again nowadays. It's only one-to-one connections. This neuron-like multi-connectivity we are not seeing. But in practice, from the vision to the practice, shared assets, what does it mean? This is a real-life picture from our factory in Vaasa in Western Finland. It's FAME AN campus, which means that even though it's actually located in our newly inaugurated factory, it's owned and operated by FAME, the ecosystem. And it means that actually, as Wärtsilä, we are only one of the users of the machine. We have 4 other companies coming to our premises, using the machines, interacting with us, and also interacting with each other, and then sharing the information and knowledge. This is not that we would be externalizing some study project for the universities, or just that we own the company, own the machine, and then just invite people to come and use our machine. But this is actually jointly operated and jointly owned. And this is something that is based completely on trust. It's not very typical to invite also your competitors to enter your premises and focus together on shared problems and shared technologies. So yeah, it consists of these 3 key ingredients, which is knowledge network, the people, shared assets, sharing the risk. So this M290 by EOS, it's paid by these 5 companies, and thanks to that, we were able to equip it, for example, OT monitoring and smart fusion systems. We cannot afford those kind of systems alone. None of these players will be, but together we are able to do it. About the shared information, this is more driven by the FAME, which again, now in this case, we are the ones who follow. We are not leading this. This is one example of common vision in practice. In FAME, in Finland alone, we have a little bit shy of 6 million people. But in FAME, we have 50 members already. So a small country can make an actual significant difference in the AM nowadays by trusting each other and actually focusing on some key problems. Everybody was saying in our industry a couple of years ago that, okay, yeah, this is nice and fun and games, but we're still missing the material data. Okay, let's do something about it. We launched this open material database project. Thanks to Business Finland funding, thanks to FAME leadership, we're actually testing and printing with each and every service provider in Finland this platform. We are testing it and sharing the results within the organization of FAME, so the member companies. We are testing impact strength, tensile strength, powder material quality when recycling, fatigue strength, and so on. 10,000 material samples on the basic materials and basic these OEM provides, what they provide as the material parameter sets. And this is only one thing that we are actually sharing. There are big companies, there are small companies, and each and every will get piece of this information. Again, this is something that GE and Siemens, they have done probably a couple of years ago, but this is not widely spread, and it's not available even for us, a company size like us. Imagine then a company which is 10 guys or something, so it's impossible, but not with this approach. Then also something, wanted to include a slide about first in the world and also first in Finland at the same time, which is new technologies. As FAME, we wanted to know that how is it nowadays, this warm technology? Wire additive manufacturing. You can produce quite a big components with that. So we selected a supplier in one of our FAME member companies, which is Andritz Savonlinna Works, because they were quite good already in the robotic welding and big industry projects. Then together we designed the pressure vessel, we tested it, and it's visible and presented in the FAME booth downstairs. If I recall it right, it was D68. So go there, check that. You will also get to see the testing results. This was burst tested, which means that we tested actually how much pressure it can take. And you will see the results. Those were quite magnificent. So first of all, it holds pressure. I can tell that. But then, as my conclusion, all the good presentations are having some sort of a quote. I choose the most corniest one that I could get, but this holds true. So if you really want to go fast, yeah, you can go alone. But then you will fatigue yourself quite easily. But then, if you want to collect, and you're able to collect critical mass around the common vision, you're actually getting quite far. So with those remarks, thanks for the attention. It's a big honor to be here in the Formnext stage. Thanks a lot.